before we tell you please. Let's go back to yesterday's lesson and show all the possible ways to write an integer by writing it as products of positive factors. We said that we'd use our rules of divisibility, and we could start with always 1 and the number itself. And we're making it into a list. 1 times 28. It's an even number, so it's 2 times 14. Not divisible by 3, but it is 4 times 7, and we're done. Let's look at the list of positive factors of 50. Well, we start with 1 and the number itself. It's divisible by 2 because it ends in 0, and that's 2 times 25. It's not divisible by 3 or 4. It is divisible by 5, and that's 5 times 10, and our list is done. I believe we've done 24 before. That's 1 times 24, and it's 2 times 12, and it's 3 times 8, and 4 times 6. 18 is the last one. 1 times 18, and 2 times 9. I think we did this one already, and 3 times 6. So there's a quick review on that. Another way you might be asked to list, instead of just a long list, but maybe pairs. This would be 1 times 40 and 2 times 20, just another way of representing it, and 4 times 10 and 5 times 8. Sort of going right down that list of rules of divisibility. 1 in the number itself, 1 times 32, 2 times 16, and if you like this method better, use it, and 4 times 8. And there's our factor pairs. Let's look at these types of question and maybe a different type of formatting. Here's a multiple choice. Which list shows all the positive factors of 15? Take a moment and examine A, B, C, and D, and select your choice, and we'll reveal the answer when we're together in class. The second question, another multiple choice. Which number is not a factor of 438? This time again, use your rules of divisibility and see if it's divisible by 2, 3, 5, 6. Find your answer, and again, we'll reveal that answer as well during our session. I want to go into a little brief discussion about powers today. Powers have two components, base and exponent. Here the base is 3 and the exponent is 4. When we look at this, this is telling me to take this base, or this factor 3, and multiply it by itself 4 times. And then we get that from exponential form to expanded form to standard form, finding the answer. In my second problem, it's telling me to take, I'll move it down a little bit, 2 times 2 times 2 times 2. 2 to the 4th power, the base is 2, exponent is 4. It tells me how many times to use this factor, this base as a factor of itself. 2 times 2 is 4, times 2 is 8 is 6. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Got ahead of myself there. The next one is 5 to the 3rd power, which is 5 times 5 times 5. That's the expanded form, and here is the standard or number form of that. And the last one, I'll do it down here for space. Take 7 and square it. 7 times 7, 49. Now, as I was saying these, 3 to the 4th, 2 to the 4th, 5 to the 3rd, which is also 5 cubed. When it's raised to the 3rd power, we call it cubed. And when we look at something to the 2nd power, it is squared. I'm just going over this just to see what you remember, and we'll definitely do this in a formalized lesson when we return from break. Before we do a little practice on this next topic, let's refresh your memory on prime numbers. Prime number is a number greater than 1, okay, doesn't include 1, is greater than 1, that has only 2 factors. Those 2 factors are 1 and the number itself. all the other numbers are called composite. So if I'm looking at any composite number, and let's just start with 20. We'll go with an easy one. We'll use what we call a prime factorization tree, and we'll start breaking this down into prime numbers. When we find a prime number, we'll circle it. Now, I start off by saying, and that's why we just did factors first, name two factors or two numbers when multiplied give me 20. Some of you will say 2 times 10, and some of you will say 4 times 5. I'm going to do it side by side to show you that we will get the same end result. Some of you will take 2 times 10 as your first numbers, and others will say 4 times 5. Well, 2 is a prime number, so I circle it, and I'm going to keep breaking this down until I get to all prime numbers. And there's my prime factorization. I'm going to write it first in expanded form, 2 times 2 times 5, and then in our exponent or exponential form, 2 squared times 5. If you started with 4 times 5, then you circled your 5 first, because that's a prime number. And then you'll find the two factors of 4, which are 2 times 2. And notice that when I write the expanded form, least to greatest here, and write the exponential form, we have the exact same answer. So when we're looking at prime factorization trees, and we're going to use them to find greatest common factor, but not in this lesson. We're going to look at maybe another example or two. Now on my next number, I'm going to start with 36. Now you could say, oh, that's 2 times 18, or 3 times 12, or 4 times 9, or 6 times 6. Remember, we just learned how to make a list. Choose any numbers from that list. Well, I might start with 6 times 6. Those are the first ones that came to my mind. And those are both composite, so I'll break it down again to prime numbers, circling my primes as I go along. And then I see that I have 2 times 2 times 3 times 3. This is what we call the expanded form. Okay, now I'm going to write it in the exponential form, which means I'm going to be putting it into base exponent. So I take the base and I count up how many there are. Take the next base and count up how many there are. 2 squared times 3 squared gives me 36. Let's just try one more. What if we had, let's say, 100? We'll do 2. This way gives you a chance to try a couple. And what if we had, let's say, 72? Try these both. You can choose any two factors to start with. And again, if you started with 2 other factors, when the final answer is put together, we should have the exact same answer. And we showed that with our opening example. I have 2 squared, which is 4, 5 squared, which is 25, 25 times 4, 100. 72, so many places to start from. Many of you will probably start with 8 times 9, one of those basic facts you know. This one is a little bit longer. I'm going to take this down all to prime numbers here. I'll do the same with the 9, and that's 3 times 3. What do I have? 2 times 2 times 2 times 3 times 3. Exponential form, 2 to the 3rd power times 3 squared. And there you have a little refresher on prime factorization.